Good day, students. We're doing kind of a finale today in our demonstrations. This one is called the Explosiveness of Hydrogen, and just to show you some of the simple things that are involved with it, we're using an excess amount of zinc, which is in this 250 milliliter flask. I've got a clamp just for security. I thought it was kind of cool. I had some of these antiques here. This is an older graduated cylinder. This one is a new one, and supposedly I've got it set right at 50 milliliters. Thought might be interesting to check it out, see how close our measurements were. And you can see it was a little bit off, about looks like 1 milliliter off, which is not bad when you consider how wide the top is. But anyway, we're going to add that to our reaction vessel. This is just going to be the medium for the reaction. All I'm wanting to do is just cover the bottom of that. I've got hydrochloric acid here, and we're going to be adding that, and we have to add it in amounts that we get a reaction that is sustainable so you can see each time I add some hydrochloric acid to that, I'm adding in about 2 and 3 milliliter increments. Now, another thing that I haven't shared with you yet is I'm using used zinc. What I mean by used mossy zinc is it has been used before, so a lot of the dust has been removed, so I don't get a reaction that is so rapid that it can actually splatter through this one. So I'm going to continue to have a sustainable reaction here for a little bit of a few minutes, okay? So I'm gonna let that continue at one more, get a good reaction going. Give it about 5 minutes or so to continue, then we'll come back and run a test on it. All right, so here's the reaction. We've got zinc, which is in elemental form, that's the solid. The hydrochloric acid was a liquid form. It's aqueous, meaning it's dissolved in water. We're predicting that we're going to get zinc chloride and hydrogen in this reaction. To balance the equation, we needed a coefficient of 2, so that makes these are the reactants, and that yields the products in this reaction. There's also going to be a second reaction. If we indeed get hydrogen, I'm going to use the igniter over there to light the hydrogen in the presence of the room oxygen to create water and excess heat. It should occur rather quickly. You have to be kind of quiet to hear the whistle. I thought while we're letting it generate, I would show you one of the ways that I set up the apparatus. Sorry, I got hooked up to the wrong one. That one's kind of froze up. Okay. Okay, I've shown y'all how to do these bending of glass before, students, but some of you that are watching for the first time may not have seen that. We've got, it looks like a little extra different additives in our fuel at the present time. Sometimes it shows up a little differently. I'll turn off the light so you can see it a little bit better. They add an additive to the methane, so methane in its purest form you can't smell. Alright, so this is just a hollow piece of tubing. Hollow piece of tubing is like I can fire polish this one like I've shown before. I'm gonna look for an orange color in it. Kind of hard to see with the other colors that are there. But you can see a glow of more intense. Go a little bit longer. I'm trying to keep it right above the inner blue flame. That's the hottest part of the flame. With all the additives in here, it's kind of hard to see. Yeah, that's rounded very nicely there. And then I'll lay it on the wire gauze again. That's just to remind me and any other student, one of the things that I coach you as students to do is to keep a wire gauze handy so that others know that at some point this was really hot, to avoid accidental burns. Because glass, as you can see, when it's hot, you can't tell. Anyway, I'm going to start the bend now. I'll take a piece of tubing that I've already fire polished both ends. I rotate it in the hottest part of the flame. I'm watching for it to start to bend on its own, and then I simply go with that bend to try to keep it as long, gradual a bend as possible. Rotating in the flame. You can see it's starting to wobble just a little bit. So I'll kind of move that like that. And you can see it's a nice even bend, kind of hold it steady. It's got a little bit of, not perfect, but almost to 90. But as you can see, it's a nice sweeping bend. And again, I'm going to lay that on the wire gauze for safety's sake. Go ahead and turn this off. And I'm going to go back and check our status. It's been almost 5 minutes or so. I'm going to go back over here, add a little bit more to it, and swap our lights. So we can kind of see a little bit. Looks like we've still got some bubbling going on there. I'm going to add just a little bit more acid to continue the reaction. As you can see, it's bubbling nicely. Still adding it. Adding hydrochloric acid to the thistle bulb. Now, if you were interested, what I was doing a moment ago, that's the bend I made previously. As you can see, it goes through the 2-hole stopper for delivery tube to go into this. Now the next step is I'm going to, if we have enough hydrogen present, I'm going to remove these gloves because try not to have gloves on when there's flame present. I'm predicting there's going to be a flame, so I want to kind of move this around just a little bit, get this piece of tubing out of the way. When this reaction occurs, I'm going to try to roll this off the end of this glass tubing. I'll use this propane igniter here, and I'll light this up here at the tip. Now, if there is hydrogen present, it should burn up here at this tubing because there's oxygen in the air around it. I'm going to try to lay this tubing off to the side. Hopefully it won't knock anything over. But reaction could be very quick, or it could take a few moments for the oxygen to come in and reach up here to the point that it will actually backfire down into this chamber. If it does, there will be a fairly loud explosion inside this chamber. So I don't know. I don't usually tell my students that. I just kind of let them experience it. But here we go. Hear the whistle? And there it was. You did hear the whistle, didn't you? And that was pretty dramatic, wasn't it? So I think hydrogen is explosive, so we need to handle it with care. Well, I hope you enjoyed this finale of our demonstrations for this season, and looking forward to many more experiences with you. I hope you have a great day. Bye.